Hi, everyone. Thank you for joining this presentation. In this presentation, I will be talking through Decipher TLS in OpenEdge. So my name is Rahul Shukla, and I am Principal Software Engineer in Progress, and I'm a member of one of the core PASOE team, so who mainly works on TLS side. Okay, so let's see what we are going to learn today. So we'll start with the introduction to TLS. So we'll discuss some basic concepts and what value TLS brings to the table. And then we will try to understand different TLS primitives using Cipher suits. And we'll talk about a little bit about the TLS configurations and what all the TLS vendors that are used in the OpenEdge. And then I'll talk about the integrity of a TLS connection, where we'll see the PKI search chain validation and host name validation. And at the end, I'll talk about TLS authentication models and some of the PKI utilities. And then we will discuss some of the use cases for the troubleshooting purpose. Okay. So first one is what is TLS. So I think many of you already know. So it's a kind of a cryptographic protocol that is used to secure the network. Okay, so basically that TLS protects the communication between the client and the server, and make sure that your data is encrypted, or your data is protected from the eavesdropper and from tampering. Okay, so that is what TLS does. So there are three purposes of TLS. First one is authentication. So here it ensures that there is a way to check the authenticity of the server. Okay, so here basically TLS checks whether the server is who they claim to be or not. Okay. Sorry. Another one is confidentiality. So here TLS ensures that even if somehow the data is stolen or eavesdropped, so unauthorized parties should not be able to read that data. So they should not be able to understand that. Okay, and last one is integrity. So here TLS ensures that there is a mechanism to verify that data has not been tampered during the transmission. Okay. So how these three things are implemented? So for authentication, it uses digital certificates. So during the TLS handshake between client and server will present his certificate to the client, and client will check the authenticity of those certificates. Okay. Similarly, for confidentiality, it will use the encryption algorithm. So both client and server will negotiate a encryption algorithm. Okay, and both will encrypt their data using that, and no one in between can understand that data. And last one is message digest. So message digest, basically, here it will generate a hash, okay, for the messages that are being transmitted between client and the server. And it will make sure that, if someone tamper that data, so that message digest will change. Okay, so it will get to know that, someone has tampered that data. And coming to the benefits of TLS, so the first benefit is it protects against the cyber threats like eavesdropping and TLS session hijacking. Okay. Then, since it's a security measure, so it helps you to reduce the insurance premium. Okay. Third one is interoperability. So, it's a standard implementation, and different technologies or different vendors implement it using the standard way. Okay. So it helps you to achieve the interoperability also. And some other benefits are it fulfills the compliance and regulatory requirements, and it also builds that trust with the customers. Okay. So this is about the TLS introduction. Now, next part of the presentation is we'll try to understand these primitives which we discussed in the previous part using a cryptographic algorithm. Okay. So on the left side, I have given the Cipher suit format. Okay, and right side we have some example corresponding to that format. Okay, so if you see on the left side we have protocol. So here we use TLS. So earlier we had another like older protocol that was SSL, which is no longer used. So that one indicates the protocol. Then we have key exchange. So key exchange basically indicates that basically it will exchange the key between client and the server. Okay, so most of the Cypher supports symmetric keys. So both client and server will exchange the symmetric key in the during the TLS handshake. Okay, so that indicates the that particular symmetric key. Then we have so here in the right side we have ECDHE. We use ECDHE for the key exchange purpose. Then we have authentication algorithm. So this is mainly for the authentication of certificate. Okay, so in general, the common one is RSA, which we use for certificate authentication. Then we have encryption bits. So in the key exchange, we exchange the key. Now this one indicates that what encryption algorithm and what is the size of that key. So here in the right side, we are using AES 128 GCM. So GCM basically points to a mode. So most of the encryption algorithms come with different modes. So here GCM is one of the supported mode for AES. We have CBC also and some other modes. Okay. So this AES 128 GCM is the encryption algorithm. Okay, and it will use the symmetry key which was exchanged in the using that ECDHE. Okay, and the last one is MAC. So MAC is in the right side, we are using SHA-256. So that we are using SHA-256 for the message digest purpose here. Okay. Now the question comes why we need to choose CipherSuite very carefully. Okay, so what all the things we need to consider while choosing the CipherSuite. Okay, so I have mentioned 3 parameters here. First one is security. Okay, so some of the CipherSuites are stronger than the other CipherSuites. Okay, and some are some of the CipherSuites are vulnerable. If I talk about some of the CipherSuites like that contains RC4 and DES, so those CipherSuites are no longer secured. So you should not use that kind of CipherSuites. Okay. Another factor is compatibility. So both client and server supports it's they have separate list of supported CipherSuites. So you should make sure that there are some common compatible CipherSuites between different parties. Okay, in order to make a secured connection. If there is nothing common, then your connection will not be successful. And the third factor is performance. So if you think your application is very sensitive to performance, okay, then sometimes choosing a very high secured CipherSuite can cause performance degradation. Okay, so you should always try to choose a balance of all these 3 parameters so that you can have a secured communication. Okay. So this session is kind of technical, so whenever you have some questions, you can ask me immediately. Okay. So now we are going to talk about the TLS configurations. So I have captured this diagram to show you the different supported vendors, TLS vendors in OpenEdge. Okay. So for C++ based component, we use OpenSSL. Okay. And for Java based component, we use JSSC. And for .NET based component, we use Microsoft implementation. Okay, so all these blue color boxes are indicates that underlying technology, underlying TLS vendor is JSSC. Green ones indicate the that underlying TLS vendor is OpenSSL, and for yellow one is for .NET. Okay, so this is yeah. No, Spring Security is Java, so that is JSSC.
Oh, sorry, yeah.
Yes.
Okay,
Yeah.
thank you.
So understanding these like underlying technologies or underlying TLS vendor is very, very important. So it tells you the so using this you can understand the default behaviors of the vendors. Okay, I'll give you some example. Like suppose you are using MS Agent, so it's an OpenSSL based component. So by default, the default cipher suits will be aligned with the OpenSSL. Okay. Similarly, for you can pick any Java components. Suppose PASOE you are picking. So we are using JSSC TLS vendor for that. So defaults will be aligned with the defaults will be aligned with the JSSC. Okay. And the way we tailor these TLS connection for these vendors, that will be also uniform. In the next slide, I will talk about how we tailor the TLS connections. So you will get more clarity there. Okay. All right. So next one is how we tailor the default TLS connection. Okay. So you need to understand this thing. So OpenEdge comes between the TLS vendor, okay, and the TLS connection. So OpenEdge provides a lot of options to tailor that TLS connection. Okay, so in previous slide I talked about SSL cipher suits. So SSL cipher suit is one of the input for the TLS connections. Okay, there can be a number of other inputs to a TLS connection, like TLS protocol, then key store, cert store. Okay, like that we have many inputs to a TLS connection. Okay, so I have mentioned all these examples here in the priority order. Okay, so first one is system level configuration. So okay, so this example is mainly for the OpenSSL based component. For Java based component, it will be quite different. Okay. So for if you want to configure system level configurations, okay, so you can use environment variables, or you can use the property files. Okay, so I have given example of setting that client TLS protocols. Okay, so when you set that one using that environment variable, that will be applicable to all the clients that are based on the OpenSSL. So if you're using MS Agent as a client, then this property will work there as well. Okay, it will work for ABL client or Provin. Okay. Similarly, if we are using DB server or some other server component, so you need to use SSL server properties there, and that will work uniformly for all the server OpenSSL server-based components. Okay. After that, we have process level configuration. So these settings will be applicable only to particular process. So we are giving the startup parameter here. Okay. So that startup parameter will work only for that particular executable. Similarly, we have connection level configuration also. So that will tailor the connection for that particular connection. Okay, so here connection level will have higher priority compared to process level configurations. Similarly, process level configuration will have a higher precedence over the system level configurations. Okay. All right, so next part of the presentation is integrity of a TLS connection. So one question might come to your mind, like how client will trust the server? They don't know one another, right? So how does client trust that it is connecting to the right server? How it will check the integrity of the server? Okay, and another part is like how it will get to know that that certificate is coming from particular host name or particular domain. So as part of integrity of TLS connection, those things are validated. Okay. So first one is PKI search chain validation. Okay. So in this validation, basically client will check the authenticity of the server certificate. Okay. So the usual process is server will send its certificate, which are signed by the private key of the third-party CA root certificate. Okay, and when that certificate comes to the client will use the public key of the CA root certificate. Okay, and then it will authenticate the certificate. Okay, so that's the usual process for checking the authenticity of the server certificate. So I have listed down the complete step. So on the right side, I have given one example actually. So this is the example of a certificate, like how certificate chain looks like. Okay, so this the last one, that yellow certificate is the server certificate. Okay, which is signed by the intermediate CA certificate 1. And then we have another intermediate CA certificate that has signed the previous certificate. And the top we have root certificate that has signed the second intermediate CA certificate. Okay, so this is how a certificate chain looks like when you involve intermediate CA certificates. Okay, so when handshake happens, at that time server will send this certificate to the client. So it won't send the private key of the root CA certificate. Okay, it will just sign this certificate chain using that private key, and along with that server certificate, it will send the public key of CA certificate to the client. All right. So when it reaches to the client, it will perform these 5 steps. First, it will try to construct the certificate chain. So it has the public key of the root CA certificate. Okay, so it will use it, and it will try to. That certificate was signed with the private key of the root certificate, so it will decrypt it and try to get the public key of intermediate CA certificate, so that it can go ahead and get the actual SSL certificate, server certificate. Okay, so first it will construct the certificate chain, then it will verify the signature using that public keys. Okay, and then it will check the chain of trust. So it will start checking the chain from starting to the last certificate. Okay, and make sure that everything is good. And next step it will do is it will check if any of the certificates are revoked. Okay, so it will. We have like OCSP and CRL mechanism. So using that, it checks whether any of those certificates are revoked. Okay, and last thing it does is it will check the validity of the certificates. So once all those things are good, then it assumes that certificate, like that PKI cert chain validation is done, and it is successful. Okay, so this is the mandatory process in OpenEdge. So you can't bypass this one. Okay, so whenever you want to use TLS, you need to have some certificate to complete this PKI cert chain validation. Okay, so after this step, it is good. Like okay, the certificate it received is genuine certificates. Okay, after validating the certificates, next thing it does is host name validation. Okay, so in PKI cert chain validation, we checked whether we check the authenticity of the server certificate. Now here we are checking whether the certificates are coming from the proper host name or not, proper host or proper domain or not. Okay, so in host name validation we do that. So this is the optional validation. You can bypass it using no host verify. Okay. So how it works? So it will try to extract the host name from the URL which you are trying to connect. Okay, and then now in this process it trusts the server certificate. So now it will go to the server certificate and it will get the common name and SAN name from that certificate. Okay, and then it will compare it. If it is matching, it is good. Okay, if it is not matching, it will fail the connection. Okay, so this is how this host name validation works. Okay, so in previous slides we talk about integrity of TLS connection, where we talked about PKI search chain validation and host name validation. Now for PKI search chain validation, we have two ways of doing that. Okay, so I'm discussing about those two authentication models here. So first one is we can either use the genuine third-party CA signed certificate, okay, which is the recommended approach. So I mean, in this approach, what you will do is you will go to a trusted, certified C authority. You will ask for the certificate, and using that, you will do the PKI search chain validation. Okay, since these certificates are issued by the third-party CA, okay, trusted CA, so we can accept. I mean, we can use this certificate for the authenticity of the server certificate. I mean, we can assume that this certificate will be genuine certificate. Okay, and so the recommendation is you should always use these certificate. Okay, and I mean, yeah, so all your public-facing applications should use this certificate. Another alternative is you can use self-signed certificate. Okay, so these certificates are basically signed by the entity itself. Okay, so we can't trust them. So it is kind of a hack to make things work, but this is not a recommended approach. Okay, so OpenEdge shipped some of the default certificates. Those certificates are self-signed certificates, so you should not use them in your public-facing environment. Okay, so yeah, you can use them in the non-public controlled environment, especially in the development environment, but not in the production. Okay. Yes, these certificates are not globally accepted, so they are not suitable for authenticity of the server. All right, so next one is OpenEdge PKI utilities. So here I'll be talking about some of the PKI utilities which we ship with the product. Okay, so first one is PKI util. Okay, so this is mainly for the key store, DLC keys folder. Okay, so you can perform all your key store related operations using this utility. Like you can create your key pair or certificate signing request using this one. Then you can import these certificates to your key store. So all key store related operations you can perform using this utility. Okay. Similarly, we have cert utility. So you can perform cert store related operations using this utility. Okay, like you can import your intermediate CA certificates into your cert store using this utility. So these are, I'm talking about DLC keys and DLC certs folder. So it will mainly work with the OpenSSL based component, okay? Like DB, Provin, etc. For PASOE or some Java-based component, you need to make changes in the different places. Then we have another utility that is SSLC. So this is the OpenSSL command line utility which we shipped with OpenEdge. Okay, so it is the same as OpenSSL utility, and this utility has lot of functionalities. Okay, which you can use for troubleshooting purpose or creating or managing your cert stores, okay, or key stores. So it has a lot of like options. You can refer to this link and see what all it offers. Okay, the fourth one is SSLJ. So just like PKI util and cert util, so this one is for the Java-based component. You can okay, and you can create your certificates for like all your Java-based component using this utility. I have given a couple of examples here, like you can use you can create key store or generate key pair. Okay.
Is the SSLJ, is it the same as key tool in Java?
Yeah. It uses SSLC also, or OpenSSL also some places. So it's a kind of wrapper. Yeah. Okay. All right. So next one is tips and tricks. So there are some tips and tricks which I follow when I create the certificate. So I wanted to share with you all this information. So first one is you need to be very careful while providing the distinguished name in your certificate. Okay, so you should adhere to your organization policy and the naming convention for providing these distinguished names. Okay, so that you can maintain consistency and compliance. Okay. Next one is you need to be very careful while providing common name and SAN names. Okay, so the problem is, okay, so these common name and SAN names should be RFC 6125 compliant. Okay, and you should use the proper common name and SAN names. For example, if you are using some specific common name and SAN name, okay, I mean some full name. Suppose you are giving that okay, this certificate should work for this particular machine. Okay, then you need to go to all your clients and you need to add no host verify there if you are using this certificate somewhere else. Okay, so you should try to avoid those scenarios. Okay, next one is related to the private key. So private key should always be password protected. Okay, so otherwise someone can copy that private key and impersonate you. And next two tips are related to the CA attributes. So we have couple of attributes like basic constraints and key uses. So we should be very careful while providing those things. So for basic constraints, we can tell whether this certificate is a CA certificate or not. Okay, so for example, if any server certificate you are putting this field as CA true, okay, then client won't be able to validate that certificate because it is considering this as a CA certificate, so it won't be able to validate the certificate chain properly. Okay. Similarly, we have key uses. So that tells how your how your certificate should be used. Okay, so we have digital signature, key encipherment, like that we have some values. Okay, so if you provide some wrong value there, then your certificate can be misused. So for example, if you mark some certificate as a digital signature, like you fill that field as digital signature, then someone can use that certificate for signing other certificates. Okay, and they can use it to enter your system. Okay, so be very careful about these things. Okay, so yeah. So far we talked about all the concepts. Now we will see some of the use cases for the troubleshooting. Okay, so here actually I have used OpenSSL and SSLC. SSLC is basically OpenSSL command line utility to reproduce these issues. Okay, so all your error messages you are seeing, you are going to see here, that are either generated by the SSLC command line utility or from Provin executables. Okay, so first use case is troubleshoot expired certificate. Okay, so in this use case, either your certificate, okay, or like either of your certificates or your root CS certificate might get expired. Okay, so what you have to do is you should renew it. Okay, so how you can check it whether that certificate, like any particular certificate, is expired? So you can automate this. You can use this SSLC command and try to get that information, that validity information from the certificate. Okay, and if you see that certificate validity is expired, then you should renew that certificate. Okay. So usually, like, we have automated this for our certificates. So like that you can do for your certificates. Okay, you can iterate through all your certificates and check their validity, and whatever has expired, remove them and use a new one. Okay. I have given another command to check whether a particular certificate is in good shape or not. So you can use this SSLC verify command. Okay, CA file will pick the root certificate from that particular location, and the certificate which you are trying to check is that test.crt. So if everything is good, then you will see some error code 0, means that verification is successful. Okay, so once you replace your certificate, replace your expired certificate, then you need to renew all the services those were consuming those certificates. Okay, another use case is you have untrusted root certificate. It means that the root CS certificate, which was required to validate some certificate, is missing. Okay, so you will get some error like error code minus 54 that says that particular .0 file is missing. Okay, for SSLC you will see the above error. Okay, so what you can do is, simple thing is, you can so you know what certificate you are using on the server. Okay, so you go to that particular certificate and try to generate the hash corresponding to that certificate. Okay, it will give you some value like that .0 value. Okay, go and search that value in the cert store and see whether that is available or not. Okay, so that is one way of doing that. So you need to have your root CS certificate in the cert store, and then you can use it. All right, so next one is troubleshooting missing incorrect order of intermediate CS certificates. So I think this is the most important thing. So in this use case, what is happening actually? So either like server has made some mistake and it has not put some intermediate certificate in the certificate chain, or on the client side we are not able, or its order is wrong. Okay. So what you will do is, first you will try to connect to the server and you will try to get the list of certificates from for that particular certificate. Okay, so in our use case, I showed you server certificate was signed by 2 intermediate CS certificate, and at the end it was signed by the root CS certificate. Okay, so similar thing when you do here, when you run this command, you will see total 3 certificates. Okay, then you can see whether any of the certificate is missing in the chain, which you think should be there in the chain is not there. Okay, so that is one way of doing that. Okay, other thing you can do is you can capture all those certificates in a separate files. Okay, and then you check the issuer details and the subject of the next certificate. Okay, so server certificate was signed by the intermediate CS certificate. Okay, so the issuer of this certificate will be the intermediate CS certificate. Okay, so like that you can check whether the issuer of this certificate is the next certificate in the chain or not. If it is not there, then that particular certificate is missing. Okay, so how you can verify your chain? So you can merge all those certificates which you received in the first step. Okay, combine them and run this command SSL verify CA file. So CA file is the public key of the root CS certificate. Okay, and then you are checking this with the combined list of certificate which you received from the server. So if this verification is successful, it means everything in the chain is good. Okay. Okay. So another use case is sometimes some of the TLS versions does not support particular signature algorithms. Okay. So you will get some error like signature mismatch. Okay. So you need to analyze that. So what you will do, you will go to the certificate and try to grab the signature algorithm inside that. Okay, it will give you the algorithm name, and you need to see whether that particular algorithm is supported or not supported for that particular TLS version. Okay, if that is not supported, then you need to generate new set of certificate using correct signature algorithm. Okay, another use case is host name mismatch. So I talked about this one when I was talking about a host name validation. Okay, so in this case, what will happen? I mean, client is trying to connect to some particular host. Okay, but the common name and SAN names specified in the server certificate is not matching with the particular URL. Okay, so in that case, you will get this error. Oh, sorry, my problem description is not right. I think I made a mistake there. Okay, so but so you can go and see the certificate. Okay, what is the common name and SAN name in the certificate, and you should try to connect using that host name only. Okay. So or you can use the no host verify, so you can bypass that host name validation. Okay. The last use case is mismatch cipher suit or protocol issues. Okay. So I talked about the compatibility issues when I was talking about why we should choose the cipher suit carefully. Okay. So this is a use case from there itself. So in this use case, client and server does not have the common cipher suit or common protocol. Okay. So how you can how you can see that error. So you need to enable the logging for client. Okay, when you enable the logging, you will see some error like handshake failure. Okay, so sometimes OpenSSL provides you cryptic error message. It won't give you the proper error message because of the security reasons. Okay, so what you need to do is you need to go to the server, okay, and enable the server logging. So in this use case, ABL client is or Provin is trying to connect to the PASOE server. Okay, so I went to the server and enabled the SSL handshake in jvm.properties. Since the underlying TLS vendor is JSSC, so I enabled that logging. Okay, and it will give you the details, like proper error message that no cipher suits in common. Okay, if you are using some other server like DB server, then you need to enable server log for like OpenSSL based component. Okay, so when you set the proper cipher suits, then your connection will work fine. Okay, so this was the last use case. Yeah, here I have listed some of the important links which you can use for creating some self-signed certificate, or how to use different utilities, how to troubleshoot TLS connection, etc. So these are the important links which you can refer. Yeah, with that I open floor for the questions.
What I struggle the most with is when I'm trying to do OAuth 2 and then JKS stuff. Because I'm always wondering what order to put in certificates in the JKS, in the Java key store, and it always fails. It's kind of difficult to debug. Essentially, what PAS does, it says I want to reach the endpoint to get the cert, but it doesn't say that it didn't work, and it doesn't say why.
Yeah, so you should follow the certificate chain properly. Okay, so yeah, so you can see the issuer details and the subject name of the next certificate. That way you can see what is the flow of certificates.
Yeah, it's not too much debugging information when it goes wrong.
Yeah. Any other question? Okay, I think we are good for today. Thank you.